Good morning, students. This is your fourth class of motion chapter. In your third class, you had studied difference between distance and displacement, speed of a body, average speed, instantaneous speed. Now, in this class, we'll be studying uniform speed, non-uniform speed, velocity of a body, average velocity. So before beginning our new topic, let's revise our previous class. Speed in a general term is distance traveled per unit time. Okay, that means distance traveled in unit time, or we can call it as 1 second also. Okay, now speed is denoted by small v. V is equal to S by T. S is the distance traveled and T is the time interval. SI unit of speed is meter per second and CGS unit is centimeter per second. Another unit of speed is kilometer per hour. This was the way that I told to convert kilometer to meter per second, or we directly can multiply by 5 by 18 if we need to convert kilometer per hour into meter per second. Okay, now what was the average speed and why did we need it? The average speed we need it because during our journey, in the case where it is not possible to maintain a fixed or constant speed during the entire journey, we need to change our speed from time to time according to the traffic. So, the case in which in the entire journey the speed is varying, that means if the speed is variable, then to sum up with for the entire journey, we need to tell that what is the overall speed of the journey. Then the term that we use is average speed. So we call that the average speed of the particular journey. Okay, now what the average speed formula was total distance traveled upon total time taken. Okay, first we calculate the total distance traveled and then we calculate total time taken, then we divide it and then we get our average speed. Now what was instantaneous speed? The speed of the object at a certain instance of time is called instantaneous speed. Instantaneous speed was the speed at particular instance of time. If somebody asks me what was the time and what was the speed at the time 12:15 p.m., then at this particular instance of time, the speed would be called as my instantaneous speed. That means the speed at this particular instance of time. Okay, now we know that at a given instant time, what we read from the speedometer is instantaneous speed. So in order to see the instantaneous speed, we look at our speedometer of the vehicle. Now, one point was left in the previous day class. Let's start with that. When a body moves with uniform speed, then average speed is same as instantaneous speed. What does this mean? For example, I have divided this journey into 3 equal parts. That means I have divided this entire journey into 3 equal distances. Okay. Now, if I say that I have traveled in the entire journey keeping my speed same, then I'll say, let's take an example that my speed is 20 kilometer per hour. That means when I have drived from A to D, from Alwar to Delhi, I had kept maintaining 20 kilometer per hour at every instance of time during my entire journey. Okay. Now, if somebody asks me that what was the time at 11:30 a.m., since I have kept maintaining my speed uniformly and that too at 20 kilometer per hour, then my speed at 11:30 a.m. was also 20 kilometer per hour. Now, my speed at 12:15 p.m. was also 20 kilometer per hour, isn't it? Now, for every instance of time, since I hadn't changed my speed, so at every instance of time, my speed was same. So, since the speed did not change, my average speed was also 20 kilometer per hour, and at every instance of time also my speed was 20 kilometer per hour only. So, when the body doesn't change its speed during the entire journey, that means keeping the speed uniformly, then my average speed will always be equal to instantaneous speed. This will be case only when my entire journey I haven't changed my speed. Okay. See, let's read it again. When a body moves with a uniform speed, that means my speed is same. Then the average speed is same as instantaneous speed. Okay. This will be same only at one condition, and that condition should be that body moves with a uniform speed. Okay. Now, define uniform speed and non-uniform speed. What is uniform speed? If a body covers equal distance in equal interval of time, then the body is said to have uniform speed. What does this mean? It means, for example, if I take the same example, okay, that I'm driving from Alwar to Delhi, and I have broken it into 3 equal parts, okay, of equal length. Let's state that the parts are of 20 kilometer each. Okay. Now, if for the time taken to travel from in this part of distance is 1 hour, for this part also it is 1 hour, and for this part also 1 hour. That means I am traveling equal distances in equal interval of time. That means if a body covers equal distance in equal interval of time, then the body is said to have uniform speed. Okay. In this part of the distance, my speed would be 20 kilometer per hour. Per hour means in 1 hour. Here also 20 kilometer per hour. 20 kilometer per hour. So at every point in the entire journey, my speed is 20 kilometer per hour. That means it is moving, the vehicle is moving uniformly. Okay. That means the vehicle is moving at uniform speed. Okay. Example of the uniform speed: motion of heavy vehicle like trucks on highway. Like, see, on highway, heavy vehicles doesn't change their speed. Why? Because they have lots of load with them in their vehicles. So in order to avoid wear and tear in the heavy vehicle, the truck driver tries to maintain the truck at the uniform speed. Okay. Now, what is non-uniform speed? If a body doesn't cover equal distance in equal interval of time, the body is said to have non-uniform speed. That means, let's take an example, the same example. Okay, now here the distance covered in 1 hour at this first part is 10 kilometer. After 1 hour, in the second hour, the distance is of 40 kilometer. In the third hour of the journey, the distance covered is 10 kilometer. So now the body is covering unequal distances in equal interval of time. That means the body is not covering equal distances in equal interval of time. While mentioning uniform and non-uniform speed, we'll consider equal interval of time and we'll see whether the body is traveling equal distance or not. Okay, so in non-uniform speed, equal interval of in equal interval of time, the distances are unequal. That means they are not equal. So if a body does not cover equal distance, like it doesn't cover equal distance in this example, isn't it? And here in the first part it was covering 10, then second part 40 kilometer, then at the last part 10 kilometers. So it is covering non-equal distances. Okay, that means not equal distances. If a body doesn't cover equal distance in equal interval of time, here the interval of time for comparison we are taking equal. Okay, so for equal interval of time, the body does not cover equal distance. Then the body is said to have non-uniform speed. Okay, now example of non-uniform speed, like the motion of the bike in the city or busy roads, right? That means when we ride on a bike on a busy road or city where there is lot of traffic, then we need to keep on changing our speed, isn't it? So in that case, the speed will be non-uniform. See, here the speed will be what? In first part, speed is distance upon time. So distance is 10 kilometer, time is 1 hour. So 10 kilometer per hour in the first part. Now in the second part, the speed is of 40 by 1 kilometer per hour. That means 40 kilometer per hour. In the third part, for 10 kilometer per hour. So this is 10 kilometer per hour. This is 40 kilometer per hour. And this is of 10 kilometer per hour. That means in the entire journey, the speed keeps on changing and it is not maintaining uniformity. That means it is non-uniform speed. Okay. Now, what is velocity? We know about velocity, that velocity is a scalar quantity. That means it has, along with the magnitude, it has sense of direction. As we have studied, distance and displacement isn't it? In distance, we have read that distance is our scalar quantity and displacement as vector quantity. Okay, this is scalar, this is vector. The same way, the speed was distance upon time. Distance is scalar, time is scalar, so ratio of scalar quantities will result to the scalar one only. So speed will be a scalar quantity and velocity comes in the category of vector quantity. Okay, so while studying the velocity, everything will be same except that distance will be considering displacement, and here will also be taking consideration of the direction. Okay, now what is velocity? Velocity, as speed is related to distance, isn't it? As speed is related to distance, velocity is related to displacement. As speed is related to distance, so is velocity related to displacement. Velocity of a body is its displacement per unit time. So velocity is displacement per unit time. Okay. Now, since displacement is associated with direction, isn't it? See, here in the numerator, displacement is there. It is what? It is a vector quantity. So, since this is it is associated with the direction, the velocity also is associated with the direction. Okay. So, since displacement is associated with direction, velocity is also associated with the direction. Okay. The direction of velocity is same as the direction of the displacement. The direction in which the displacement will be there, the same direction will be of velocity also. Okay. Now, what about the SI unit? Since velocity and speed gives the intention how fast the body is, so their unit should be same, isn't it? Likewise, in the distance and displacement, they were giving the intention of the length, so their SI unit were meter for both of them. So here they both give the sense of how fast the body is moving. So since the speed was having SI unit as meter per second, so velocity will also have same unit. Okay. So now the SI unit of velocity is meter per second, and we can write it like this also. Okay, the same as speed. And in CGS system is centimeter per second. Other units of velocity is kilometer per hour, kilometer per minute, etc. Define uniform velocity and non-uniform velocity. Also define average velocity. As we have already read about uniform speed, non-uniform speed and average speed, in the same way, now we are going to study uniform velocity, non-uniform velocity and average velocity. Now, why do we need to study average velocity? When in the entire journey there is change of in the velocity and there is no fixed velocity throughout the entire journey, then overall journey will be considered according to its average velocity. Okay. When the velocity of a body is not constant, means not fixed, then we find the average velocity for the time interval. Okay. So average velocity is The average velocity of an object is its total displacement divided by the total time taken. Okay. So the formula of average velocity is total displacement upon total time taken. Okay. Or we can also define it in other words as it is the rate at which an object changes its position from one place to another. Here, the rate means it is with respect to time, means it is divided with time. Okay. So, if any quantity is divided with time, then we call this as rate of the numerator quantity. Okay. So, here the rate will be rate of displacement or rate of change of position from one place to another. Here we are studying with respect to displacement because see, as I already told you, as distance is for speed, the same way displacement is for velocity. So in the previously we were studying average speed, then we were mentioning here total distance traveled. Now we are considering average velocity, so we have to consider the displacement. Okay. So what is the SI unit of average velocity? The same as that of velocity only, and velocity has the same SI unit as that of speed because both shows how fast the object is moving. So SI unit is meter per second, same as speed. One more thing, if we have to find the average velocity, there is a special case in which in case the velocity of the object is changing at a uniform rate. What does this mean? It means that, for example, it is changing at a particular fixed rate. It means that let's consider that in the starting the velocity was 40 kilometer per hour. Okay. Then the velocity gets 42 kilometer per hour. Then velocity changes to 44 kilometer per hour. Okay. And this will be kilometer. This k will be always small. Okay. So if it changes from 40 to 42, then further to 44. So the rate of change is that it is, let's take an example that after 1 hour it changes plus 2 kilometer per hour. Okay. After another hour it changes plus 2 kilometer per hour. Okay. So if every 1 hour the velocity increases to 2 kilometer per hour. Okay. So it is changing uniformly, isn't it? It is changing at a uniform rate. If this would be the case, then that the change would be uniformly, then there is a special formula that says average velocity as initial velocity plus final velocity by 2. Students, in this question, 3 definitions were asked. In this video, I could cover till only average velocity. This uniform velocity and non-uniform velocity I'll be covering in my next class. Okay. So all the notes which are being provided to you, write it as it is and write this question as it is. Okay, and in the next class again put the heading uniform velocity and non-uniform velocity and continue. Okay.